Good day everyone and welcome. Today we delve into the fascinating world of AI in video gaming with our research titled PANGeA, Procedural Artificial Narrative using Generative AI for Turn-Based Video Games. We explore how AI can revolutionize narrative generation, particularly focusing on enhancing the dynamism and personality of non-player characters. Stay tuned as we unravel how PANGeA mitigates out-of-scope responses and aligns content with gameplay rules, offering a new horizon in interactive narrative design. Let's begin. Our research is primarily motivated by the desire to enhance narrative generation in video games. We've taken a deep dive into the existing applications of AI for content creation, and have critically examined the innovations in procedural narrative generation and interactive storytelling. This exploration has allowed us to identify key areas for improvement. However, we've noticed that existing models have certain limitations. They often exhibit bias and performance issues, and they struggle to account for every problematic narrative generation scenario. This is the problem statement that our research seeks to address. We aim to overcome these challenges and push the boundaries of narrative generation in video games. Our proposed solution, PANGeA, uses a unique approach to guide generative responses. It injects desired biases into the narrative by using instructions. This is particularly evident in the creation of non-player characters, or NPCs, where we evoke the Big Five personality traits to generate personality-biased agents. Now let's talk about the evaluation and results. We had human evaluators review the generated responses for narrative alignment. The results were quite revealing. In an ablation test, we found that without PANGeA, the large language model, or LLM, generated more out-of-scope responses. However, with PANGeA, these responses were significantly mitigated. The content was better aligned with the game rules and the designer's criteria, demonstrating the effectiveness of our approach. Video games have emerged as a powerful medium for interactive storytelling, offering players a unique, immersive experience. The dynamic interactions within these games significantly impact the player's experience, shaping the narrative in real time based on their decisions and actions. Now, let's delve into the heart of our research, PANGeA. As you can see in the figure, PANGeA is a structured approach that leverages large language models, or LLMs, for the procedural generation of interactive narratives in turn-based RPGs. It's designed to address specific challenges in interactive storytelling, offering a novel way to generate content and enable dynamic responses to player input. This high-level overview of PANGeA's key components provides a glimpse into the intricate system that powers this innovative approach to game narrative design. We've identified a key problem in the realm of procedural narrative generation: the challenge of implementing dynamic responses to player input, and the limitations of early research that focused mainly on coherent sequences of events. Our proposed solution, PANGeA, addresses these issues head-on. It leverages large language models, or LLMs, to create interactive narratives in role-playing games. Not only does it generate level data, but it also fosters dynamic interactions during gameplay. What sets PANGeA apart is its unique approach. It injects high-level narrative criteria into a prompt schema, which guides the generation of playable narrative assets. These assets include landscape settings, key items, events, and non-player characters, or NPCs. This approach allows for a more immersive and interactive gaming experience, pushing the boundaries of what's possible in narrative design. PANGeA's custom memory and validation systems are key to maintaining narrative consistency and aligning generated responses with gameplay rules and the unfolding narrative. These systems tackle the challenge of varied and unpredictable text input. The validation system evaluates this input within the scope of gameplay rules and narrative, ensuring that the generated content remains relevant and immersive. Moreover, PANGeA operates through an iterative process. It interprets previously generated content as instructions, which guide the unfolding interactions between players and the environment. This approach allows for a dynamic and engaging gaming experience, where the narrative evolves based on player input and actions. This innovative approach to interactive storytelling in video games showcases the potential of leveraging generative AI in game design. PANGeA, standing for Procedural Artificial Narrative using Generative AI, is a novel approach to procedural narrative generation in turn-based role-playing games. It's not just about creating static content. Instead, it's about fostering dynamic, free-form interactions between the player and the environment during gameplay. At the heart of PANGeA's unique approach is the generation of level data during the game's initialization. This is where the game designer's high-level narrative criteria come into play, shaping the baseline narrative of the game. But the innovation doesn't stop there. As the game progresses, PANGeA continues to generate content, responding dynamically to player input. This creates a rich, interactive narrative experience that evolves with the player's choices. In essence, PANGeA is about bringing the game world to life, making it responsive and adaptable, and ensuring that the player's actions have a meaningful impact on the unfolding narrative. Our research introduces a unique approach to narrative generation in video games. Game designers can inject high-level narrative criteria into PANGeA's prompt schema. This information is then parsed by a server-aided game engine plugin and provided as instruction to a large language model, or LLM. This process allows for the generation of playable narrative assets. The LLM can generate landscape settings, key items, and events, creating a rich and immersive gaming environment. Additionally, we introduce the concept of personality-biased non-player characters, or NPCs. These NPCs are capable of engaging in free-form dialogue with the player, adding depth and dynamism to the gaming experience. In essence, our research proposes a novel way of using LLMs to create interactive, engaging narratives in video games based on high-level criteria provided by game designers. Our research introduces the concept of personality-biased NPCs. These NPCs are unique in that they express the Big Five personality traits when generating responses. This results in a diverse range of responses, each reflecting the unique persona of the NPC. Moving on to server integration, we've designed a server with a REST interface. This allows any game engine to directly integrate with PANGeA, enhancing its versatility. The server includes an LLM interface, a custom memory system, and a novel validation system. The LLM interface facilitates communication with the language model, while the memory system stores context from each prompt for use in subsequent prompts. The validation system, on the other hand, ensures that the generated responses align with the game narrative. In essence, our research proposes a comprehensive system that not only generates engaging narratives, but also ensures their coherence and relevance to the game's context. Our research introduces a unique validation system. During the initialization phase, the large language model, or LLM, generates gameplay rules. These rules are not static, they are dynamic and interactive. As the game progresses, the validation system uses self-reflection techniques to evaluate whether the player's text input aligns with these rules and the existing narrative. But what happens when the input doesn't align? This is where corrective responses come into play. If the validation system detects input that deviates from the gameplay rules or narrative, the LLM doesn't just reject it. Instead, it generates a corrective response, guiding the player back into the narrative. This ensures a seamless and immersive gaming experience, even when unexpected player inputs occur. Our technical results have been quite promising. We tested PANGeA in the Dark Shadows demo game, where it successfully generated interactive narratives. The NPCs in the game were personality biased, adding a unique layer of depth to the gameplay. PANGeA was able to align the generated content with the procedural narrative and gameplay rules, ensuring a coherent and engaging experience for the players. Furthermore, PANGeA offered guidance to users by reiterating gameplay rules and narrative context, assisting players in understanding and immersing themselves in the game world. These results highlight the potential of PANGeA in enhancing interactive narrative design. PANGeA represents a significant stride in the realm of procedural narrative generation for role-playing games. It employs large language models to create interactive narratives, bringing a new level of dynamism to the gaming experience. The system generates content in response to the high-level criteria set by game designers, allowing for a tailored and immersive narrative experience. The figure here illustrates the importance of PANGeA's validation system. It shows an instance where the language model generates an out-of-scope response to the player. This underscores the need for validation steps to ensure the narrative remains consistent and engaging. PANGeA brings unique contributions to the field of interactive narrative design. It offers a server with a REST interface, allowing direct integration with game engines. It introduces a novel validation system that maintains narrative consistency and an LLM interface that supports a variety of local and private LLMs. Furthermore, it features a custom memory system that stores game data, enhancing the depth of player environment interactions. Our empirical study and ablation test, conducted in the demo game Dark Shadows, demonstrated PANGeA's effectiveness. It aligns generated content with the narrative and gameplay rules, and uses input text evaluation to guide the generation of responses. Lastly, PANGeA addresses the challenge of varied and unpredictable text input. The validation system evaluates text input against gameplay rules and the narrative, generating a corrective response if the input does not align. This ensures a coherent and engaging gaming experience. Our custom memory system plays a pivotal role in supporting nuanced player environment interactions. It returns context to augment generative content and promotes narrative consistency, ensuring a seamless gaming experience. In terms of interactive narratives, we've made significant strides. We've created NPCs with personality biases, aligning their responses with the procedural narrative. This system is robust enough to handle irrelevant text inputs without derailing the narrative, maintaining the integrity of the story. Lastly, we've prioritized user guidance. Our system reiterates gameplay rules and narrative context, assisting players in learning the game. This ensures that players can fully immerse themselves in the game, enhancing their overall experience. In conclusion, our research has led to the development of a system that not only generates engaging narratives, but also provides a user-friendly gaming experience.